In this video, I'm going to solve a few integrals using substitution rule. So let's do first example, integral of e to 2x minus 1 dx. So this formula reminds me of integral of e to the x dx, which is e to the x plus c. But we don't have e to the x, we have e to 2x minus 1. So we are going to make a substitution, u equals 2x minus 1. Now let's find the differentials for this. Du is the derivative of this with respect to x. So 2x minus 1 prime is 2. This means dx is equal to du over 2. So if we go back into our problem and we start replacing, we have integral of e to 2x minus 1 is equal to u. So it's e to u times, instead of dx, we'll put du over 2. So du over 2. This 2 that is at the denominator can come in front of the integral. So now integral of e to u du. Now it's pretty identical with the formula that we wrote here. So I'm going to erase it to make room. So I'm going to get 1 over 2 e to the u plus c. But our original problem was in x, so it's 1 over 2 e to 2x minus 1 plus c. Final answer. Example 2. Integral of sine of 5x plus 2 dx. Now this formula reminds me of integral of sine of x dx, which is equal to negative cosine of x plus c. So in our case, since we don't have just sine of x, we're going to take this and, I thought I was highlighting. We're going to take this quantity, 5x minus 2, and we set it equal to u. So u equals 5x plus 2. So du, it's equal to 5 dx. So dx is du over 5. So then this integral becomes integral of sine of u times du over 5. So 1 over 5 is going to be brought up in front of the integral, and integral of sine of u du, it's exactly using this formula, so it's 1 over 5 negative cosine of u plus c. But our original problem is in x, so this is negative 1 over 5 cosine of 5x plus 2 plus c. If you differentiate this, you're going to get exactly sine of 5x plus 2. Let's do another problem. Integral of cosine of x over 3 dx. So again, it's not just cosine of x, it's cosine of x over 3. So let's do u equals x over 3. So the differential du is, if we differentiate this quantity with respect to x, we get 1 over 3, and we write the differential dx, which means dx is equal to 3 du. So when we go back into this, we get integral of cosine of u times 3 du. Now the 3 comes in front of the integral, and integral of cosine of u du, that is equal to sine of u, because sine of u prime is cosine of u, plus a constant. So we replace back u with x over 3, and we get 3 sine of x over 3 plus c. Example 4. Integral of dx over 1 plus 4x squared. Now this integral reminds me of dx over 1 plus x squared is equal to arctangent of x plus c. So in our case, let's rewrite this as integral of dx over 1 plus, well, 4x squared can be written 2x, everything squared. So because it's not just x squared like we expected in the formula, it's 2x squared, I'm going to set u equals 2x. So du is equal to 2 dx. So dx is 2 du over 2. So if we replace in this equation, we are going to get integral of, instead of dx, we can put du over 2. And I'm going to put 2 here. And then 1 plus u squared. So instead of dx, we put u. Now, a half can come in front of the integral, and we get integral of du over 1 plus u squared, which, if we use the formula that we wrote here, it's arctangent of u plus c. But the original problem was in x, so it's 1 over 2 arctangent of 2x plus c. Final answer. Example 5, integral of dx over square root of 4 minus 9x squared. Now this integral reminds me of integral of dx over square root of 1 minus x squared. It's equal to arcsine of x. Well, in our case, we don't have 1 minus x squared, we have 4 minus. So what if we factor out the 4? So we get square root of 4 times 1 minus 9 over 4x squared. And then I moved out the 4 from the square root. So it's going to be 1 over 2 integral of dx over square root of 1 minus, and instead of 9 over 4x squared, we write 3 over 2x, everything squared. So this starts looking more and more like the formula that we wrote here. So let's write u equals 3 over 2x. So du, it's equal to 3 over 2 dx, which means that dx itself is going to be 2 over 3 du. So in our case, we are going to get 1 over 2 integral of, instead of dx, this dx, we are going to put 2 over 3 du. So 2 over 3 times, and let's put the du at the end. We usually have the differentials at the end of the integral. And then 1 over square root of 1 minus u squared. So the constants, we can move them outside, and we get 1 over 3. And then the integral that is left, it's integral of 1 over square root of 1 minus u squared du, which is arcsine of u plus c. So we get 1 over 3 arcsine of 3 over 2x plus c. Example 6, dx over 25x squared plus 81. Now this problem reminds me of the formula. You see how it's good to write the formulas all the time. A squared plus x squared, so equals 1 over a arctangent of x over a plus c. Well, in our case, let's write this one. How can we write it? We can write it as integral of dx over 5x everything squared plus 9 squared. So just by comparing our problem, we have a to be 9. But x is not x, we have 5x. So let's do u is equal to 5x. So du, it's 5 dx, which means just dx by itself is du over 5. So let's write this. This is a formula. So this equal sign continues down here. So we get integral of, instead of dx, we put du over 5. So let's do that at the end. And then 1 over u squared plus 9 squared. Now why 1? Because this is a 1. I actually consider this integral to be integral of 1 over 5x squared plus 9 squared dx. So this is why the dx from here was substituted with du over 5. So we get, based on the formula that we wrote here, is going to be 1 over 9 arctangent of u over 9 plus c. But u, it's 5x, so it's 1 over 9 arctangent of 5x over 9 plus c. And this would be the final answer. Let's solve a definite integral. Integral from 0 to 4 of 9 over x squared plus 4x plus 5. Well, this is an interesting problem because we don't have formulas exactly like this. But when we see a trinomial like this, we try to complete the square. Complete the square. Now, how do we do that? Well, to complete the square, we copy the first two terms, and then we add the middle term, the middle constant, divided by 2 squared. Well, this is equal to 4, so we add a 4. But originally in the problem we had a 5. So then I have to do 4 plus 1. Now this trinomial, it's exactly x plus 2 squared and then plus 1. So this integral becomes 0 to 4 of 9 over x plus 2 squared plus 1. At this point, the only two formulas that we have with squares at the denominator are arcsine, but that involves radical, and arctangent. So in this case, let's write u equals x plus 2. So du, it's exactly dx. Now let's not forget the limits of integration are just for x. So what I'm going to do is, if x equals 0, u equals 0 plus 2, so it's 2. If x equals 4, u equals 4 plus 2, so it's 6. So this integral becomes integral from 2 to 6 of 9 over u squared plus 1 du. Right, I replaced everything in it. This x plus 2 was the u, and then the dx was replaced with just du. So this one, it's equal to 9 comes in front, then we get arctangent of u evaluated from 2 to 6. No more a constant, right? So we get 9 arctangent of 6 minus arctangent of 2. Now, this problem, well, I don't know what arctangent of 6 is, right? Tangent of what angle it's 6, or tangent of what angle is 2, so I'm just going to leave it like that. Let's do example 8. Integral from 0 to pi over 3 of cosine of, Let's do problem 8. Integral from 0 to pi over 3 of sine of x over cosine to the third of x dx. Now, let's take a look. Which one of the functions looks more complicated? Sine of x or cosine to the third of x? Well, cosine to the third. So if I look at cosine to the third of x as a composition of functions, it would be, the outer function would be x to the third, and the inner function would be cosine of x. So let's set u equals cosine of x as our substitution. So now du is going to be negative sine of x dx. Or in other words, sine of x dx, it's negative du. So if we go in this problem, and instead of sine of x dx, right, this quantity, sine of x dx, we put negative du, and at the bottom, instead of cosine to the third of x, we put u to the third. Now we got a much simpler problem. So, the limits of integration are going to change as well. So let's do this. If x equals 0, then u equals cosine of 0, which is actually 1. So the new limit of integration is from 1. If x equals pi over 3, u equals cosine of pi over 3, which is cosine of 60 degrees, which is 1 over 2. It goes from 1 to 1 over 2. So now let's calculate this. This equal to negative integral from 1 to a half u to negative 3 du. So this is pretty easy to see. I'm going to continue here. That is u to negative 3 plus 1 over negative 3 plus 1 evaluated from 1 to a half. So let's simplify this a bit. Now we get u to negative 2, negative u to negative 2 over negative 2, which means 1 over 2 u to the second evaluated from 1 to a half, which means 1 over 2 times 1 over 2 to the second minus 1 over 1 to the second. So we get 1 over 2 times 1 over 1 over 4 minus 1. 1 over 1 over 4 means actually 4, so we get 3 over 2. And try this example 9 as a practice. I'm going to work it out as well, but try and solve it on your own and check if you get the same answer that I got. So here is the work, and the final solution is at the bottom. Please pause the video, check if you got the same answer, and look through the work to see where you made a mistake or if you did it correctly. Good job. I hope this is going to help you.